Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Allahumma rabbana atina fid dunya hasanatan wa fil akhirati hasanatan wa qina adhaban nar. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Complex numbers. This is the introduction class of complex numbers. In this lecture, I will discuss the basic concepts of complex numbers. A number of this form is known as complex number. Find the link of the math website in the description where you can find the soft copies of all the lectures and this lecture as well. An important advice: hard work always pays off. The introduction class of complex numbers. What are complex numbers? A number of this form is known as complex number, where z means complex number and both x and y are real numbers, and this iota is an imaginary number and read as iota. This small I means iota, and its value is under root minus 1. Well, this x is a real part of this complex number, and you can write this as real part of z, re. This means real. So real part of this complex number z is x, whereas its imaginary part, im means imaginary part of this z is y. These are few examples of real numbers. If we multiply real numbers with I, then these numbers will become imaginary numbers. So for imaginary numbers, we just need to multiply I with real numbers. So these are the examples of a few examples of imaginary numbers. Comparison between real numbers and complex numbers. In real numbers, we label horizontal axis with x and vertical with y. Whereas in complex numbers, we label horizontal axis as real axis, in short RE, and vertical axis as imaginary axis, in short IM. In real numbers, we represent point by means of dot, whereas in complex numbers, we represent any point by means a cross. We use cross to represent complex numbers on Argand diagram. In complex numbers, the diagram is known as Argand diagram. This diagram is known as an Argand diagram. Well, in real numbers, we use bracket to represent the coordinates of point, any point. But in complex numbers, we do not use bracket. We write the number as it is. Don't use brackets for complex numbers. In complex numbers, we take same scale on both the axes. If we have repeated complex numbers, then we use cross and circle on Argand diagram to represent repeated complex numbers. Since z and v both are same, so we have to use cross and circle. Well, to understand the structure of complex numbers, we must first introduce a new set of numbers, this set of imaginary numbers. I told you, if we multiply any real number with I, then we can get imaginary number. Well, imaginary numbers are of the form bi or iy, where both b and y are real numbers, and I is known as iota, and its value is under root minus 1. So if you multiply 2 with I, you will get imaginary number. and I square is minus 1. The imaginary number I is called the unit imaginary number as it has a coefficient of 1. You can read I as iota, and it is also called as unit imaginary number because its coefficient is 1. Now, how to use I? Well, if we have to evaluate under root minus 9 in complex numbers, then we can write minus 9 as under root 9 times minus 1, and we can split the root. So we have under root 9 here and under root minus 1 here, and we all know under root minus 1 is I and under root 9 is 3. So under root minus 9 is 3i. So in complex number we have to write under root minus 9 as 3i. What if we have to evaluate under root minus 5? So we can write under root minus 5 as 5 times minus 1, then we can distribute root to both, and this will become I, so under root 5i. So the answer of under root minus 5 is under root 5i. Under root minus 18, we can write this as under root 18 times under root minus 1, and this will become 3 root 2i because under root 18 is 3 root 2. You can do this directly if you have understood this concept. You can directly write under root minus 9 is 3i. Well, always replace under root minus 1 by I in complex numbers, and never replace I by under root minus 1. Never. So under root minus 1 is I, under root minus 3 is under root 3i, under root minus 16 is 4i. Since under root I is under root minus 1, therefore I square will be minus 1, and I cube, you can write I cube as I square into I, and it will be minus 1 times I, so it's minus I because I square is minus 1. Similarly, you can evaluate I power 4. You can write this as I square into I square, so minus 1 into minus 1, so it's 1. It's here. So this is the way to evaluate higher powers of I.